Hi everyone, welcome back to DeriveIt, and we're going to be solving this problem. So this problem involves paths through a binary tree. A path has to go through two nodes in a connected way. So this might be a path, or this might be a path, but the path can't diverge off in this direction. So the thing to realize is just that the path always has a node on the very top that you have to go through, and then it branches downwards in a straight way on both sides. So in this problem, we have to find the path with the biggest sum inside of a tree. So the biggest, it's pretty obvious for this example, it's just going to be 15 plus 20 plus 7, because these are the biggest numbers in the tree. And so we should return 42 in this example. And so we're going to want to use recursion to solve this problem because we're dealing with a binary tree. And so we might try to make the maximum path of the root node we're given recursive. And if we do this, the only thing is the root node or whatever node's on top of the path, it's kind of privileged because it can split off, but the other nodes in the path can't really split off into other paths. And so this is going to be hard to make recursive. What we kind of have to do is we have to consider the path where it goes straight down to the left and straight down to the right. So we'll consider the path where it goes straight down to the left, the max path down of the left. So we're going to call some sort of function that takes in the left node, and it's going to tell us the maximum path we can go by going straight down from the left node. And this is a different function than the max path, just because it has to be simpler than max path. It can't split off. And then we'll do the same thing for the right node. In order to find the max path through this root node, it's definitely going to involve the root.value. But we have to consider all the different cases. We can either go left, or we can go right, or we can go through both of these sides, or we could go through none of them. So these are kind of our four cases where we add nothing, or we add the left one, or the right one, or both of them. And we don't really care if this left subtree had like negative 5,000 inside of it. We only care about the biggest one of these cases, and so we're going to want to take the max over them. So this is the max path that goes through a single node in the tree. You know, it's not going to tell us the max path through the entire tree. It's just going to tell us the max path that involves this root node over here, or some root node. But this is a good starting point because we have this simpler function over here, max path down, that we probably can make recursive. And so we're going to be able to hopefully hijack this thing once we have its recursion. And we're going to be able to compute the max path throughout the entire tree. And so let's just try to make this recursive and see if we can hijack it in the first place. Okay, so I just copied over the result that we found. And now let's try to make max path down recursive. So the max path down from this node over here, for example, it would have to include the value of that node. And then we might branch down to the left or to the right in some straight way, but we're not going to branch down to both of them, obviously, since we're only considering the max path down. And so it's going to be similar to before, but now we only have to consider the max path down to the left and right, and not to both of them like we did before. So this is going to be our recursion, and it actually is a recursion because we have max path down on both sides of this equation here, or this code. And so now that we have our recursion, we need a base case. And the base case is when we get to some node that's null, the max path down is just going to be 0. Just intuitively, this is true. And so we have our recursion and base case, and so we can pretty much solve the problem. And we can hijack this function because it's kind of computing everything we wanted in order to find this function up here. It's computing the max path down of the left and right nodes, which is exactly what we needed up here. And because this function is recursive, it's going to go down the whole tree and compute these things. You know, it's not just going to compute them for the root node. So we can just hijack this function to find the thing we want. Okay, so let's code this up. We have to declare this recursion as a function so we can actually call it. And then for convenience, we can call these things ML and MR. We're already doing that up here. And we're obviously going to return whatever's here. I guess I said root, I meant to say node. And then we have to check for the base case on the very top. So this is the recursion and base case for this maxPathDown function. And now we want to hijack this function so that it computes the max path throughout the entire tree. And we know how to hijack it. The max path that goes through a node is just going to be this thing over here, so we can figure out the max path that goes through a node. Let's just call it M. So we're going to find the maximum path that goes through every single node in the tree when this recursion is called. And so we can just use some global variable called the maximum path we've seen so far. And every time we find a new max path through a node, we can just update the max path that we've seen so far. And so this is gonna update the global variable. We've successfully hijacked the function, and we just have to initialize this. We can make it -infinity at first. And then when we actually call this maxPathDown function on the root node of the tree we're given, it's going to go down every single node and find the max path and update the max path we've seen so far. And we can just return that as our answer. So this should work. One thing we're forgetting is we need to say non-local to this variable because it's defined outside of the function. And so let's just see if this works. Okay, so this was a pretty good solution. So now we have to find the time and space complexity. And so we're obviously going to have to go through every node in the tree. The time complexity is O of n. And so the space complexity is just made up by the call stack because we're doing a recursion. And so we're not dealing with balanced trees. The call stack might grow to the depth of the tree. And so the depth of the tree is just going to be O of n. That's going to be our space complexity. These are the complexities, and this is an optimal solution. Hope this was helpful, and I'll see you again soon.